Quantum mechanics. Quantum mechanics was developed in 1925 by the physicists of the Copenhagen School. The special theory of relativity was developed in 1905 by Albert Einstein. Relativistic quantum mechanics is the combination of quantum mechanics and relativity. Classical particles are spatially confined. There is no wave associated with a classical particle. However, in non-relativistic quantum mechanics, there is a wave associated with each non-relativistic quantum particle. This is a fundamental difference between classical and quantum particles. Waves are not spatially localized. The quantum particle can be wherever the associated wave exists. This is the particle-wave duality characteristic of quantum particles. In quantum mechanics, the analytic expression of the wave associated to a particle can be found by solving wave equations. In non-relativistic quantum mechanics, if the particle has spin 0, the wave equation is the Schrödinger equation. But if the particle has spin half, the wave equation is the Pauli equation. However, in relativistic quantum mechanics the wave equations to solve are the Klein-Gordon equation, if the particle has spin 0, and the Dirac equation, if it has spin half. Alternatively, one can solve a pair of Schrödinger-like PPGP equations if the particle has spin 0, or a pair of Pauli-like PPGP equations if the particle has spin half. This means, there are two waves associated to each relativistic quantum particle. There is no wave associated with a classical particle, but there are two waves associated with a relativistic quantum particle. This suggests that a classical particle may be a naked quantum particle. If a quantum particle lost the associated waves in some process, then the naked particle behaves like a classical particle. The relativistic quantum particle has total energy equal to Ea plus mc2, if it is in a common wave studied in non-relativistic quantum mechanics. But the relativistic quantum particle has total energy equal to Ev, mc2, if it is in an exotic wave, which is not studied in non-relativistic quantum mechanics. A free quantum particle has positive kinetic energy if it is in a common wave, but it has negative kinetic energy if the particle is in an exotic wave. The kinetic energy of a classical particle is always positive. However, a relativistic quantum particle can have negative kinetic energy if it is in an exotic wave. The existence of quantum particles with negative kinetic energy is related to the existence of antiparticles. An antiparticle is also a particle. It has the same mass as the corresponding particle but opposite charge. For instance, the positron is the antiparticle corresponding to the electron. The antiproton is the antiparticle corresponding to the proton. The hydrogen atom is formed by an electron and a proton. An antihydrogen atom is formed by a positron and an antiproton. All these topics are covered in a recently published book titled Relativistic and Non-Relativistic Quantum Mechanics, both at once. This book was published in September 2023 by Springer Nature, in the undergraduate lecture notes and physics book series. The book was written by Professor Luis Greve de Peralta and his collaborators from the Department of Physics and Astronomy at Texas Tech University, Lubbock, Texas, USA. This book is based on the use of the Poveda-Poya-Greve de Peralta, PPGP, equations. In addition, the authors use the PPGP equations for illuminating discussions about the following topics: the frontiers between the classical and the quantum worlds, how the interplay between quantum mechanics and relativity determines the existence of black holes, the observed asymmetry between matter and antimatter, A Spanish translation of this book is also available in Breve.